all the mathematics already in the architectural drawing, I assume. But by if we get the accurate lengths, we can always laser cut the angle templates. So they would drop into all the angles. You have your lengths cut on the first one, then you weld that one up, and then that becomes your template. Then you can start stacking. But to start that first one, it becomes really difficult because where do you start? How do you align? But if you have all your lengths cut to size and then laser cut the inner, the inner angles for templates, just imagine around with this angle. This drops in here, 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 here. It's in tack weld, and that is now.
So we should get you some plate
so
steel?
it's basically 2 steps. Template on the.
We should just
laser.
buy you some plate steel and make it happen.
It wouldn't be plate steel. It would probably be just 1/4 inch MDF or some kind of mason
Okay.
of some
What do
sort.
you mean laser cut?
Because we get it into Zach.
We can cut a laser cut template. Basically, it looks like a protractor,
Oh,
right?
you
It
mean
follows
out
this
of
angle
wood.
out of wood, and
So you're
it
cutting a
would drop
triangle.
in here on all the angles
Yeah.
for the first one, for the first set. Now, because otherwise, there's no way of aligning that. I mean, you're gonna have to go off of this. You're gonna have to,
There might be an opportunity, you're right, maybe there's opportunity, on some of them, if you have a lot, maybe you could even laser cut the, that little T-bevel thing I showed you, you laser cut the angle, just match it to that, lock it.
That's what I'm saying,
start
right.
transfer.
Yep.
We might even be able to use that. But
and then you weld that together. That becomes now the template for the stacked method, right? Things get stacked on welded. Circle, I think, are good.
Dude.
Guys, turn it, or excuse me, counterclockwise, open this valve all the way, it happens to be open right now. Open it all the way so it's full. This is a regulator, this side tells me how much pressure is in my tank, it has pressure. Then on the other side it shows me my out, how much is actually coming out. It's really important that the gas is flowing. Usually I go through this whole spiel about why, about how it displaces the local environment. It basically moves away the air, so when we weld it, it pushes the contaminants out. In this case, we have some contaminants to deal with, but it's critical your gas is on. So can I kind of reduce this lecture? This is what you need, okay? So gas goes on first. If you look at here, the reason let me just show you this one really quick because it looks a little more complicated. But in a second you'll see why there's a lot of lines in the way. But if you look up here, this first dial says continuous. It should be on continuous. Stays on continuous. If it's on continuous, which it should be, forget those 3. That leaves us with 1, 2, 3 dials. Those 3 dials are the same dials that are on all of our MIG welders. If you look right here, 1, 2, 3. What are they? You have your on switch. This is the wire speed. If I turn it down to 0, it's going to be, right? I always tell people, do temperature set. Start at 330. But you know what? You guys are all welding the same thing. It's going to be identical every time. So, record your settings. I've welded this. What I'd be running at is somewhere like 440, 438, somewhere just maybe the wire speed slightly under 40. But just think about it this way. We could set it at 4, wire speed 40. If we're not getting enough wire or it doesn't seem hot enough, guess what? We just turn the temperature up. You might want to take, when you're making all those cuts, you're going to get a certain amount of drop. Clean those, set them aside. Practice on those. Get used to working with those pieces. That's the very thing that you'll be doing. Right? So learn on those pieces. Get your temperature set up on those pieces. I'm not 100%, but I'm thinking from my past history, it's around 440 is what you want to weld that stuff with. That would be a good place to start. All right? Look what happens when I push this. Everyone always gets scared like fire. So it's not fire, it's electric. What happens is there's a lot going on here. Usually when I do this, I unreel this first. This line is really important because it has electric coming through it, it has the wire coming through it, and the gas coming through it. So sometimes people are struggling, and they'll be like, Mark, I can't figure it out, it's not working. Oh, you guys are crazy. So you're going to be building parts, and I'll tell you what, you're going to see in a minute, we're going to put these parts together. They're kind of manageable, but once you put 2 pieces, then you put 3, you put 4, it's not going to fit on the table. You know where you guys are going to be working down here, right? So you're going to do your layout on the floor, you're going to actually be building it on the ground. Right? And I think your parts are going to fit in this space. In the event they don't, we're going to move cables out. So you'll be working on the floor. It's perfectly fine to work on the floor.